Welcome to Bawashi Electric once more. I had someone inquired on how to wire an automatic transfer or changeover switch, like designing your own DIY. Yeah, automatic changeover switches, they have different ideas. It depends on the engineer or the technician, the functionalities that he or she desires, and also sometimes it depends on the type of power supplies you're using, the type of the backup you're using, AC, DC, AC, AC. So I'm just going to try to give a simple elaboration, and we are going to make our own simple circuit between AC transfer switch. Both backup and the mains are going to be AC of the same type, and I'm going to design a 3-phase, but you can just use this screw and come up with your own transfer switch according to your own desires and functionality. I'm going to have here my power supplies. I'm going to have this one is going to act as the mains, and this one is going to act as the backup. Just going to rotate them around. Because I'm going to wire moving upwards. Now this one, as I've said, if I name them, is going to act as our mains. And this one, our backup, we are going to use maybe a generator, an AC 3-phase generator, standby. I'm going now to give them power breakers. I'll have here a circuit breaker for the mains, then I'll have a circuit breaker for the backup. Now then we are going to use contactors to change over. Then I'm going to have here, this one is a circuit breaker for the load. Now for easy simulation, allow me include a load, and in my software I don't have a house or whatsoever to put, but your load can be a full domestic house, can be a machine, can be anything. So me, I'm going to use my 3-phase motor just as a load for easy simulation. Thank you. Now let's do the wiring. That is mains, like that. Then I will have this one is line 1. I'm going to take to the load at line 1. Then 2, I'm going to give the load at line 2. Then 3, still I'm going to give the load at line 3. Then our backup, this line 1 is going to join here line 1, like that. Then line 2 is going to join line 2. Then line 3 is going to join line 3. Then here we shall move our power to the load. Nice. Now that is the power line. What's remaining is the control now. And before we go to the control, I'm going to, this one is the breaker for mains, let me call it SM. Then this one breaker for generator, I can call it SG. Then this one breaker for the load, can call it SL. Then contactor for mains can be KM. Then contactor for generator can be KG. On the power control and the control line, I'll have here 2 power supplies, so one and that one. This one will be, I'm getting it from mains. I'll get a single phase from mains, and here I'm going to get a single phase from generator. Then I'll have respective circuit breakers, of course. Now those control breakers, these control breakers shall be operated at once with these ones. Now this one is the main circuit breaker. I'll also call this one just S main. Also call this one SG, or generator. Now I'm going to have to design some selector switch that is going to help us change between automatic and manual mode. And I'm going to design a double pole, double throw selector switch. I'm going to design it in this format. Double pole, double throw. This is one selector switch and I can call it S1. The same with this one, S1. So here, if you're designing such a circuit, you'll have to look for a double pole, double throw circuit breaker, selector switch, in case you're following my circuit. But remember, I told you we have different ideas. And I will also now have the second selector switch in case when we are in manual, it is going to switch between mains and generator. That is when we are in manual, and I'm going to use a double pole single throw but with opposite contacts. Something of the sort. Now I'm going to have, of course, my coils now. This one is KG, that is the contactor for generator. This one is KM, that is the contactor for mains. So let us draft our power. I'm going to have here this live. This is the live for generator. That is it. Now when this selector switch is in normal condition, that's normally closed. It is normally, at normal conditions, it's normally closed, is going to be in manual mode. That means our switch is always, when initially it will always be in manual. Then it is the user to choose between automatic. So we are going to have it like this. So to power the KM and the KG, we shall need at least some interlocking. Shall have here the normally closed of the friend. Now this one is KG and this one is KM. They are going to power their respective friends like that, here like this. So now here this one is going to come from here and powers there, this one from here and the powers there. That is the logic, as simple as you have seen. That is in a manual mode. Selector switch S1 is in a manual mode. It will be supplying the selector switch S2. This S2, name it S2. It is the one which selects between the mains and the generator. Now we are going to design for the automatic. Now in my automatic, I'm going to add some 2 gadgets. Before I add those 2 gadgets, I'm going to have a relay. The role of this relay is the one which is going to be changing over the mains contactor and the generator contactor, but that relay is going to be powered by the timer. Now here, different engineers use timer for different reasons. Me, I'm going to use a timer in case when power comes for a short time, on off, on off, on off. The timer can help to delay those short time when power comes on, so that it can only after a given time you set a durable time, that after that time is when the timer will have to power the relay. Then the relay will change over to mains. But when the power is still in that flickering format, on off, our timer is going to still keep our circuit or our load on backup until it is stabilized. That's the role of the timer. And I'm going to design a timer in a way that it is going to work only once it changes from backup to mains, it goes off. Once it powers the relay, for it goes off. So that means here I'm going to pass it through the normally closed of the relay. Then I get here the normally open of the timer to power the relay. Now since the timer is going to go off, the relay has to self-hold itself. I'm going to have here, it is normally open contact. So when I do the wiring, I'm going to have, this one is the channel for automatic. I'm going to have it like this to the timer. Are you seeing? Then from the normally open of the timer to the relay. Are you seeing? Then the relay is going to self-hold itself, because the timer at a certain time is going to go off. Then we shall now have the relay to power the mains contactor. Now I'm going to have the normally open of the relay around here, and it will have to get the power, and it will power the contactor. Are we there? What about, that is when mains is on. What about when mains is off? We shall get the normally closed of the relay. It is going to power the generator. That is when power is off, the relay is going to be off, and now we shall be using it is normally closed, and we shall be getting power from here, because this is the channel for automatic and a backup, like that. Are we getting? Then I'll have here my neutrals, complete them. So this neutral here, it will have to come and complete this contactor. Then I'm going to have also this neutral is going to come and complete its respective components. Please, my fellow engineers, this is not all about a transfer switch or a changeover switch. Remember, I've told you this is just a simple basics so that you can develop a clue from there. I'm just trying to answer my friend to give him a clue on how he can come up with. Don't forget always the addressing accordingly. So this is S1, this is S2, this is timer KA. So here also my timer, I'll name it KA, or you can name it anything you feel like. Then this is a relay K, it is the same K, it is the same here K, it is the same here K, it is fine. I don't think if there is anything remaining. Actually, let me put some indications. I'm going to have some pilot lamps here, and I'm going to have this pilot lamp for load available. This one, I mean that one for generator, for main is available. Then this one to show load on main is. Then this one, generator available. Then this one to show load is on generator. Hope you are getting. This indicator lamp is going to show that mains is on, and this one is going to show that the load is on mains. This one going to show whether cancel. This one is going to show whether the generator is on, and this one is going to show whether the load is on generator. Now how are we going to wire these ones? I'm going to have the normal open contacts. This one is for mains, this one is for generator, and I'm going to have, let me get their neutral straight away forward. Then also I give them their respective neutral. This one is a joint here, and this one is a joint here, like that. This one is going to complete here, this one is complete here. So this one is getting from the mains, of course, and I'm going to have from, where can I get it, a bit here, mains, you see, up to here. That one shows mains available. Then this one shows the load is on mains. Then for generator, I'm going to get this one to show generator available. Then this one is going to show that the load is on generator. I think, let me try to name them. Here I'm going to mains available. Then this one ML means mains on load. Load is using mains. Then this one is going to be generator available. I see. Okay. Then this one is going to be GL, meaning that the load is on generator. Like that. I think I'm done. For a hint, we can get the idea from there, so we can carry out our simulation and see. But don't forget to name these contacts. Again, it is moving. Naming it, that one is KM for the mains, and this one is KG for the generator. Okay, now when we do here a run, initially our system is all off, mains is not available, generator is not available, everything is off. Here the selector 1 switch is in manual mode, and selector 2 switch, it is on mains. I think initially it is on mains. So when backup is on, our backup available GA generator available lamp, it is going to light. Are you seeing? Mains is not available, and the load is not using any. Let me first complete here the breaker for the load. Are you seeing? Are you seeing here the main breaker for the generator is on, showing there is power for generator coming. But since we are in manual mode and our selector 2 switch is still on mains, that's why generator is on but it is not working, the load is not using. So when you come to selector switch 2 and select now generator or backup, is when it is going to show now generator available and GL, the load is on generator. I see. When you go to mains, it is off. Now when it is in backup and we have mains is also now available. You see, mains available. Even this way, the breaker for mains is on, power is coming, but still we are on, the load is on generator because we are in manual mode, and in manual mode the selector switch has selected here generator. Now when we select mains, you see, we go to mains. Now our motor is running using the mains. As you see, it is the mains contactor which is closed, but the generator is also available. Even the indicator here shows, but it is not on load. Now what happens when we switch here to automatic? Remember, in automatic I've designed in a way that the switch prefers mains unless when it is not available. So when you select automatic, it will go in backup, then it comes on mains. Now here the timer counts. Remember what I told you is when the power is on, off, on, off, on, off, the timer first holds. Now here main is available and the load is on mains. Are you seeing? Generator is available but still the load is on mains. That is automatic mode. Let me try to increase some time here to 3 seconds maybe, or 5 seconds. Like power comes back for 5 seconds before we can leave the generator and come back to power. So when I simulate that one, here we were in automatic, and when we are in automatic, this is the load breaker, backup is on. So in automatic, it has to be, the load has to be on. So when there is backup, it will use the backup. Now when mains comes, you see here mains not available. When mains is available, the timer will first count, waiting for it to stabilize. I see. Then after stabilizing, the timer goes off. Remember I told you for it after switching it goes off. It powers the relay and the relay has powered the mains contactor. As you see, it is now mains available and ML mains on load. Also generator is available but not on load. So I cannot explain exclusively here, but you can do the simulations more. So when you get the software, this one is called Cade-SIMU, you can try out this circuit and try to see different functionalities that you would like to have in an automatic changeover switch. Then also you can come up with your own ideas. Remember I told you this is just a basic to give you a clue on how to develop your own complex transfer switches. So when it is in automatic, here the manual selector switch is null and void. Even though you choose backup or mains, backup or mains, it doesn't work. I see, it doesn't work. So let me take back my switch in manual mode. That is selector switch 1, manual mode. So manual mode, it has remained on mains just because here also the selector switch between them was on mains. But when I take it on backup, it will go on backup. When I bring on mains, now when in manual, when using this selector switch, there is no need of the timer working. No need of the timer, because by the time you change to mains yourself, you will be knowing that the main is now stable. I see. And also by the time you change to generator, you will be knowing that the generator is available. Now to understand this simulation is between here, this power line and our load, and these indicator lamps, and also these coils. Try to analyze, can reverse. Thanks for watching. I think in the next part, if we happen to meet, we shall see the real wiring of the real components. But thanks for your support. Don't forget to subscribe, like, comment with your concern. See you when you see me in the next circuit.